Can you all see my terminal?
Yes.
Okay, so what I'm going to talk about today is SQLite full text search. So this isn't specifically related to Linux, but our topics are kind of Linux and open source stuff. It's more probably more relevant to like software development and that kind of thing than systems administration, but there are some kind of general interesting fun use cases for it. So I'll start with what full text search is. It's basically just a database with indexes optimized for quickly searching through large volumes of text. So think like autocomplete interfaces, like searching through document contents, like a content management system. Um, let's see, can you see my browser now? Is that showing my screen correctly? Okay,
Yep,
perfect.
you're good.
So for example, searching a forum, like um, so this is using Algolia, which is a SaaS provider of a full text search service. So this does like very fast searches on, you can see thread titles, contents, comments, everything, and it can, search through massive amounts of text very, very quickly. But there are plenty of smaller use cases that, where maybe you've outgrown, say, like simple string comparison-based queries, but you don't need a server. Um, so if you have an application that's like just running on one machine, has just your shared file system, SQLite full text search is a really nice option. Um, for anyone who's not familiar with SQLite, it is it's basically an embedded database. It lives, the entire database lives in a single file. So you can, it's very commonly used to store application state as like, so like Android apps, like it's super common in Android apps, like to store app state. It can be like, it can be the main database for a full production application, with some, limitations, and it's embeddable. So, some, web applications can, embed a SQLite database of, WebAssembly and things like that. So I'm a huge fan of SQLite. I use it for a lot of things, but the full text search piece is what I'm going to focus on right now. So as a really simple example, I am going to try to replicate uh, apt package search. So, uh, so, so apt cache search will basically search all of the package names you have cached locally. Um, after it's read from repos. I'm going to. So what I'm going to do is basically kind of dump the contents of that, load it into a database, and kind of show off how to use SQLite full text search. Um, so if you do apt cache search dot, that'll dump everything. We'll just kind of throw that into a text file. And to make it a little easier to work with, I'm basically going to convert that to CSV. So it's just kind of a hackish sed statement to, you know, uh, split those into package title and description and wrap them in quotes. So yeah, now it looks like that. So I'm going to just, so to create a new SQLite database, you can just use the SQLite 3 CLI and just give it a database name. I'm just going to call it demo.db, so that already creates the file. Creating a text search index is really easy. The only difference is it's a virtual table and you use an extension name to create it. So it's create virtual table. I'll call it package FTS using FTS5. That's the name of the extension. And then I'll give the columns name, comma, description. Whoops, what did I do? Oh, hey, I see I had a leftover from briefly practicing this demo. Let's try this again. Let's just do that. Okay. So now you see that actually created a whole bunch of internal tables. You don't need to worry about any of those directly, except for the FTS table you've manually created. So what I'm going to do to load in that apt package data, there's the shell, or the SQLite shell has a import command. There's a bunch of different ways to load data from CSV. The .import is, kind of handy. It can load from, various text formats. I'm just going to give it a file name. What did I name that? And I tell it where to load it. Whoops, that didn't work. Okay, what did I do wrong? Okay, so first of all, I'm going to switch over to a different CLI utility called Light CLI. It's a slightly nicer interface with tab completion, that kind of thing. Okay, so what I wanted to do, .import. Okay, there we go. Looks like just a couple errored out. So now let's see what we got. So we've got 78,000 records in there. So it's not exactly the volume of text where you really need full text search, but it's good enough for kind of demonstrating what this is capable of. So how you query this, you can query it like a normal table. That's where name equals, all right, let's say curl. And that was a typo. Do. Okay, so you can just query it, like you normally would, but what the FTS extension gives you is the match statement. Where would help if I get the column name. There we go. Okay, so let me just expand that. Okay, so now this isn't doing a exact string match. This is doing a text search, and the way it searches is a little different than you might expect. It's configurable, but the default behavior is basically geared towards how most people commonly search for things. So it's not substring search exactly. It splits things into tokens, and there are different tokenizers you can use. The default one will, basically kind of split on non-word characters. So this, you see the results here showing basically anything with curl in the name as a token. If, for example, let's see. So you might also be familiar with the like operator. So that can be used as like a case insensitive substring search. So the like operator, the percent symbol there, for all intents and purposes, is like a wildcard. So that's gonna search for anything with the string SQL in the name. And I can see that gave 573 results. if I use the match statement, that's a bit different. That gave 42 results to start with, so only containing, the token SQL. There is also a star operator. It's also not what you'd expect. It's not a wildcard like with glob. It's actually a token prefix. So that'll basically search for any token. Again, depending on what, you can configure the tokenizer you use, prefixed with that string. So now we will get things like SQL alchemy. So the default tokenizer would treat that as one token, but it's prefixed with SQL, so it matches. And now we get 163 results. So just to, here's a little query prepared ahead of time. So this will just kind of show the differences. So we'll like basically do a diff between the results from the like operator and the results from the match operator to give you an example of what doesn't match. So libsqlite 3, full text search doesn't match that right away because it isn't splitting that into separate tokens. So that's, I won't dwell too much on that, but I will show how to use a different tokenizer. So the order algorithm is one example. So I'm just going to open another database right now. I'm going to create a fresh table. And the FTS5 extension has this tokenize parameter. And this is basically saying start with the ASCII tokenizer that just kind of splits on any non-ASCII word characters, like 1 through 127 or whatever it is, and then pass that to the Porter algorithm. So that what that does is that's for kind of common variations in language, like word endings and variations that substring matching doesn't catch. And I will show you an example in just a sec. So let me import that data again. And okay, an example. So let's do this. In race. So this, okay. So this is a good example. So this tokenizer is able to match some like word race with racing. So it's able to match on kind of common variations, tenses, that kind of thing. So if I switch back to the first database I made and run that same query with the default tokenizer, it does not match that. So let's see, there's a bunch more features I can go over, but before I go too much further, I'll maybe kind of go through some quick examples of how to, like use this in a script or something. Not necessarily a full application, but got one here, and that's just a bash script. So this is just in a little while loop. This is using a couple basic SQLite shell features, .mode, and .separator. So this will just kind of format the output similar to how the apt cache output looked. So if I run that, and spits out the output. So not terribly exciting, but that's a real basic example of doing it from the command line. Let's exit out of that, and whoops, and a similar example in Python. This just shows that. So Python, the standard library, very conveniently comes with a distribution of the SQLite 3 binary, so you don't have to install it. I mean, most Linux distros already come with it installed anyway. But if you're not on Linux, or there actually are some environments that don't have SQLite by default, but it has a DB API wrapper around that. So just run some other short searches, and okay, so now to go like kind of closer to an intended use case for this, gonna try to do like a basic autocomplete interface. Gonna hop over to VS Code here, and I slapped together a little TUI using a framework called Textual. If you're not a Python developer, the details don't matter too much. The important part is just, we're using the same kind of match operation here, just kind of gonna wrap that in something that will run searches in real time the way an autocomplete interface would. So let's see if this still works. Okay. So what this is doing is basically whenever you type, it's, running another query. With one important distinction that most autocomplete interfaces have. So if you listen for every single, key press, you're going to be, it's going to add a noticeable delay. So what you do is basically wait for X number of milliseconds after the user stops typing. And Python, you can just do a simple timer using async IO. Basically, it'll just fire off a task, last 200 milliseconds. If it's been less than 200 milliseconds since the last one, it'll cancel that, launch a new one. And then basically that's just a way of kind of like making it feel a little bit snappier. So let's,
Wouldn't it be better to have under MVC to have those kind of controls somewhere in the system separated from the core code?
sure. I mean, and yeah, in a real application, sure, this is just a very simple demo I threw together. In a real world application, I mean, you'd probably be using some kind of UI framework, either, a web framework or a desktop GUI or desktop application framework that has features like that built in, and you just point it to a function that gives autocomplete results. Usually you wouldn't be building something like this from scratch. But if you did, that's roughly how you'd start.
No problem. I just was curious about that.
Any other questions so far before I go any further? Do the general concepts make sense? So let's see, another way. So first of all, this isn't exactly giving the lightning fast results that I intended to show off. That was supposed to be instantaneous. I must have done something wrong with the TUI, but let's do some simple timings actually. So if we run, uh, at cache search, should I search for lib32. That's a really common phrase. Okay, so that took 1 second. If I to just copy paste this. Starting the same thing using the text search database we just built. 17 milliseconds. So that's quite a bit faster. You can optimize that down quite a bit. You, I mean, you can get like, single digit or even sub-millisecond responses depending on how much you tune it. Let's just, and so the results might not be exactly the same. So let's just kind of count up what that gives. That search gave 618 results. 632 results for app cacher. So actually pretty similar. Um, and I don't know what app cache is doing behind the scenes. It's probably doing a lot more than just searching a database, but that's at least we're in the ballpark of the thing we're trying to emulate. Let's see. Next thing to talk about is, so a common use case is you don't necessarily want to load the text search index directly, but you will have some source table and you'll want to automatically load a text search index based on that. And you can do that at the application level in code and whatever language you're using. You can also do it at the database level with triggers. So um, I'm going to wipe out. Actually, I'm just going to delete that database and start over. All right, so now what I'm going to do is I'm going to create a regular table to store the same information, and then I'm going to make triggers to automatically update the text search index when that updates. So first, I was kind of copying and pasting from my notes here because I don't want to type all that out. So brief recap on triggers. You can basically, it's kind of an event-based thing. So you can listen to events on a table, create, insert, update, delete, and run a statement or a custom function or something. They're not as common in software development these days. It's a pretty low level construct. It gets really messy to maintain if like critical application logic depends on triggers. But if you're, so that's at the application level. If you were like a library or framework developer, um, you can get some nice performance gains out of using triggers. So there's some trade-offs. So you could do all this in software, like, have a wrapper for, inserting your record that also updates this thing. This just does it at the database level, which is a little bit faster. Okay, so that's for inserts, and we're going to do the same for deletes and updates. And then we're going to import the data again, except instead of importing it into the text search database, or text search table, we'll insert it into this table that has the triggers on it. And I forgot to do the thing. I forgot to create the text search table. There we go. Did I break the database? I probably did because I created triggers that reference something that didn't exist yet. I haven't done that before. So let's try it again. It's the best way to discover new and exciting ways to break things is to give a demo on it. Fun fact. All right, that should be importing data. All right, now let's check on those tables. And we can see, okay, our triggers loaded everything into the text search table. So let's test that stuff out. So if we, um, let's insert a new record. Someone give me a facetious library name. Um, uh,
Des Moines Public.
and um, actually, there we go. Okay, so now let's compare those table counts again. Okay, so the tables are still in sync. Um, match. Oh, let's try. There we go. Now let's do a delete. Let's just pick one to delete at random. Um, let's delete VHS. Okay. Except we're going to delete from the source table. And run those counts again. It's still in sync. And update. I'm going to update the description for libgc. And it was updated. So looks like all of our triggers are working. So that having like a source table and then having a subset of that indexed separately is probably closer to a real world application. Usually you'll have something that, you'll want to query with normal queries with, a bunch of other columns associated with it, and then just take the subset of those that contain text that you want to search and throw it in a separate text search index. And let's see, I guess I'll pause there and ask again if there are any questions or comments or things you'd like me to demo or kind of, or any other questions kind of related to what I've talked about so far.
No, I think you're doing great. Just wanted to point out some of the conversation in the chat
Ah,
around, let's see, that it's also heavily used in iPad, iOS, and Mac OS. I think I threw in a comment about the max database size of a SQLite is like 281 terabytes, so it's far bigger than what you'd expect. And then Jared chimed in about how it's a someday skill that he wants, so it's useful even if it's not useful right now.
yeah, I am a big fan of SQLite. Something I actually learned recently. So the name doesn't mean it's not light as in lightweight. It's like SQLite, ite as in like a geological suffix, like a mineral, like a mineralized form of SQL, which I don't know, I think is kind of clever. Um, But yeah, I've used it for a lot of applications. I've kind of pushed it to its limits. It it can it can be like, the main data backend for a production application, where it starts to kind of break down is when you have a massively distributed application. So you wouldn't use it, for example, if there's no shared file system, if you have an application like, running behind a load balancer on multiple, computers, you wouldn't want to do this over NFS. That just adds another layer of mess. Concurrency in general takes a little bit of fiddling to get right, like the larger, like Uscala, like the number of threads and stuff. So multi-threaded reading, no problem at all. It can do concurrent reads. For concurrent writes, internally it locks and serializes writes. So there are a lot of ways to kind of shoot yourself in the foot if you're doing like multi-threading and multiprocessing with SQLite. It just takes a little bit of extra work to get it done. It can handle it though. That being said, if you have something that's massively parallel, like hundreds of threads or processes, then you're probably outgrowing SQLite, and kind of usually the next logical step would be either a full relational database like Postgres, or Redis if it's more like a caching application, which is what I've worked with. Um, but it's for a lot of things, it's kind of my go-to. It's like my starting point, and then when I have a reason to move off of it, I'll use something else. Although my use cases might be different from others. Um, it's So yeah, I've used it as like kind of the main application state database for one kind of desktop app I work on. I've used the full text search feature for like an autocomplete feature, and I've used it as cache backend for HTTP caching and quite a few other things. But yeah, that like I said, the places where I tend to outgrow that is if it's a really heavily distributed application, or it's there's just no shared file system. I want to say there is a project that's like that aims, I can't remember the name of it, that basically aims to be like a distributed version of SQLite, but I can't remember the name of it off the top of my head. That said, so the difference, there are some other subtle differences. There are a few like standard SQL operations it doesn't support. So I think it's very limited in alter table instructions, for example. So if you have an application that uses database migrations, so if you're not familiar, um, if you have an application backed by a relational database, over time you'll often make changes, and you'll want to kind of track those changes and be able to deploy them in a kind of reproducible way and in a way you can undo. So a migration is like a unit of like, here's a single change, here's how to move from the previous state to the current one, and how to move back. Those rely heavily on altered table statements, so that's a case where SQLite isn't a great choice. I think there are some workarounds, but anyway, that's just another example. Okay, so how am I doing for time, Andy? Or I guess how long would you want me to go?
You're you're doing great. You can go for as long as you want. Traditionally, usually they last about an hour, but if
Okay,
we hit a natural stopping point before that, or if we hit I mean, I'd say probably 4 or 5 hours from now, everyone else is going to be asleep. But other than that, you're doing great.
4 or 5 hours from now. Okay, that's what I'm heard. I'm gonna keep talking for 4 or 5 hours, and it's all your fault. No, actually, maybe like another 20 minutes or so. Okay, so I'm gonna switch gears a little bit and talk about a real world application I use this for. Well, it it's a small hobby project, but I'm working on a desktop application. It's related to biodiversity data. Without going in too much in detail on that, long story short, it uses taxonomy data, like biological taxonomy. And I'm gonna hop over to So this is iNaturalist. So this is like a community science platform that I both kind of use as a hobbyist nature photographer, and I maintain some software built on it. I maintain like a Python API client for it, and some other like data access tools. Um, but the part I wanted to show here was okay, so this has a very handy, or at least for me and for other people with similar use cases, a very handy autocomplete search for species names and other taxonomic names. So so this right here um, was something that I really wanted to have in a desktop application. So I kind of went down a very long and deep rabbit hole of figuring out how to duplicate this myself. Um, so what this is doing, this is running full text search on both scientific and common names. Um, so so I can search for a Latin name, um, or a common name. Um, and I wanted to be able to do both of those. Um, so what I started with was so iNaturalist does happen to have a REST API, and it even has an autocomplete endpoint. That looks like that. Um, So the request is you just give it a search query, spits out a bunch of JSON. Let me uh, slim that down with JQ. Search for jumping. And then, so this is a case where like it's not giving a direct match, saying like, oh, you want jumping spiders. That's matched against the Latin name for the jumping spider family, which is Salticidae. If we can just kind of wrap that in a little function. Let's make that a little bit faster. But I want to use this for an autocomplete interface like this, which requires for an autocomplete interface, it needs to be reasonably snappy. I mean, this one's, in the web UI here, it's a little slow, but it's still, it's still fast enough. When you're using the REST API, it is slow and rate limited. So 600 milliseconds, you really want something, closer to 100 or 200 milliseconds before it starts feeling clunky. But then the rate limiting is what was really getting me. So I wanted to, have this in real time, spit out results as you're typing, and that was just kind of blowing through the rate limits. It's a non-profit organization. They've got to keep the lights on, so they, for third-party users, they limit it pretty heavily. It makes sense. It was a pain though. So that was my motivation for wanting to build my own full text search database. So the typical options would be, so Elasticsearch would be kind of the go-to for an enterprise application. I have worked with Elasticsearch and maintained an Elasticsearch cluster myself. It was kind of a nightmare. It's really nice to use if someone else is maintaining it. It takes a lot of babysitting. I didn't want to babysit an Elasticsearch server. Uh, an intermediate solution would be like, so a lot of, so Postgres, Redis, and MongoDB all have full text search features. I've actually used Postgres full text search in the past. It's really nice. This was just a case where it's a desktop application. I didn't need a server. So what I started with was, so basically had to kind of start with the raw data and work from there. So let's see. I'm not sure if I can easily show you. Um, Let me just kind of, actually, let me open up my notes editor here. Okay, so this is an example of kind of raw taxonomy data. It would be like an ID and the various ranks. And then there's a separate data set for common names in a whole bunch of different languages. So I the details of like getting from there to a text search database is kind of like specific to biodiversity data. Probably don't want to spend too much time talking to a Linux user group about that. If anyone's interested in the details, I'd be more than happy to talk about it. But one thing I do want to cover is search ranking. So this is an interesting case where the the top result by text matching isn't always the thing the user most wants to see. So if I search for cow, um, this is smart enough to give me domestic cattle, even though that's not in the Latin name. It's not even a commonly accepted common name, but at least on this platform, it's what most people or it's what most people would expect to see when they think of cow. Other ones would be so this family birds that would include cowbirds. But if we just do a text search on this, so I'm gonna skip over a whole bunch of steps and kind of open up a text search database that I made based on that raw data. Let's see. Okay, so I have this taxon FTS table that the main difference here is I have another column that I use for search ranking. But first, let me do select. Um, let's see that. Oops, wrong table. Okay, so these are text search results by text similarity. When a user enters cow, they're most likely not thinking of mountain cow, cow knob salamander, or crested cow wheat. um, so how do we, kind of shape this to be more like what a user would expect? What I did, and so I'm not exactly sure what they're doing on their backend. They're probably doing a lot more fine tuning than I am. But so this is a platform where there are taxonomy records and observations. It's all based on observations, which would be like a photo, recording, something else. So how at least one influencing factor is like the number of times people have observed these different species. So more commonly observed species would be at the top, maybe not necessarily the first result based solely on that, but it would be heavily weighted in that direction. So I basically did a species count. One gotcha was it's not a flat list of species, it's a whole taxonomy tree. So if I want to search for cows, for example, or bovines, that's a family. So I would want to know, like, all the observations of all the different genera and species under that family. So basically made a program to crawl through the whole taxonomy tree and add aggregate data, including like the total number of observations at each level in the tree, and then normalized that and ended up with, so this count rank value, that, long story short, that's a normalized indication of like how commonly it's been observed by users of iNaturalist. Separately, there is kind of a hidden attribute called rank in SQLite FTS5. You can query on it and order on it. So there's already this rank that's based on text similarity. So what I am doing is a query like this. So I'm basically, so that value is negative. So a lower value is actually more relevant, including that internal rank value. So I'm basically taking that, taking my normalized count rank value and combining them, and then sorting based on that. And then I get, okay, so it's still not perfect. The top result is not domestic cow, but it's much closer. So if I like, okay, what is this? Cow bunting, that is the common name for brown-headed cowbird. That is one of the most, commonly observed organisms with the string cow in it. So this one has, 69,000 observations. The second one was cow fetch. That has also 69,000 observations. So this is weighted partly by just text search relevance and partly by number of observations. To fully replicate what the website does would probably take more work than I want to put in. This was good enough for me, so this is what I ended up with. And to kind of show what that looks like in the final product, if, wait, that's not what I wanted. I'm just going to launch this application and it still works. Segfault, come on. Okay, this may have been in an intermediate state of development and has some bugs I haven't fixed. Let's try that again. Okay. So this is, yep, so basically this autocomplete feature is backed by that text search database I just showed you. So if I search for it, pretty much instantly pops up what you would expect to see. What's another one? And then behind the scenes, that's pulling data from the API to populate the metadata, the images, and all that. So that, again, it was a very deep rabbit hole to go down. It was like, this is just a hobby project, not working on it for a full-time job or anything, say it's probably, I don't know, like a year or so on and off of kind of hacking away at that, every once in a while to get that right. But I was pretty happy with the result. And that was why I was interested enough to give a presentation on it. So I think that's pretty much all I had to talk about. Any other questions? Any other tangents you guys would like to talk about? And I wanna
Well, I
talk more.
mentioned that there's a very famous taxonomist in biology, Carl Woolsey, in the chat.
Oh, yeah, I haven't been taking a look at the chat. Okay, well, I always enjoy a taxonomy related rabbit hole, so I will check that out afterwards. And Andy said, be curious to read in some log files using rsyslog for some log parsing.
Is this publicly available at all? Should we look at it at iNaturalist.org?
Yeah, iNaturalist is open to the public, so it's used by both kind of hobbyists and scientists. So I'd say like maybe like half the user base would be people like me, just kind of a casual hobbyist, like nature photographer, just kind of casually interested in nature. Half people might be like field biologists or people working in a particular field that uses the biodiversity data from it, or kind of uses it in some kind of professional capacity, or education too is a kind of use case for it. I just enjoy it because I like taking pictures of things and then having people help identify them. As for my side project that is on GitHub, uh, I'll share. Let's see. I'll share in the chat at link to.
Are you in Iowa or are you far, far away? I didn't catch the intro.
He's in Iowa.
I'm in Iowa.
Well,
Been
I'll
to the
definitely.
meetings in person before, Dan.
Yes. And
In fact, he even occasionally comes into the office.
sometimes. Yeah, if you want to,
Oh, I know some people that are doing stuff in nature preserves of various sorts, and so this looks very, very powerful for what they're doing. Plus, I don't know what other tracking it has built into it, but there are several places, even this here in the central Iowa area, that this could be very useful.
yeah, it is. So it is very useful. So things that people use it for, like professionally, would be like at a large scale, would be like tracking invasive species, endangered species. A lot of people use it who are kind of specialized in one particular thing. Like I've learned so much, like just from like kind of bumping into experts in odd niches I never knew existed before. Like I talked to someone who told me all about socially parasitic ant species. Just because I took a picture of an ant that I thought was cool. And like, oh, by the way, you can see its vestigial wing scars, and this queen will like invade an enemy nest and pick off its workers one by one and make it, you know, obey it as their new queen. And like, oh, that's cool. I never would have uh, otherwise run into things like that. But otherwise, things like nature preserves, sometimes they'll have their own biodiversity data platform. Some preserves do use something like this to track their own data. Some would use this in a supplemental way. There are a bunch of different use cases for it. If you know anyone who is interested in kind of biodiversity data, or kind of using that using this in a more technical capacity, like for data analysis or anything, feel free to ping me. Otherwise, yeah, if you're interested in like nature photography or biodiversity at all, I highly recommend it. That's now many steps removed from anything Linux related, but I did say I was open to going on tangents.
We always aim for Linux adjacent.
Yeah.
One question on your actual terminal setup. What is your just admiring the complete graphics here? What do you have set up for your prompt there?
My prompt. So the prompt so there's just a fish shell. I have a custom prompt that's just my user, host, abbreviated directory, and virtual environment, and then a Git repo that'll also show that. There's plenty of like plugins that do things like that. I kind of made a bespoke version, but like for Z shell, oh my ZSH would be a common one that gives you something like that. You can build something like that in Bash. Let's see, what is my Bash prompt looking like? It's a little more bare bones. But finish.
What can I say? I'm a sucker for a great login and also way too lazy to set up my own.
Yeah, so what is looking for actual? No, that's not my prompts. Okay, I can't remember actually where I configured the prompts. It's somewhere in my dot files. But anyway, it's not too hard to do. If I can send you a link to it later. The rest of it is WesTerms, the terminal emulator, has some nice features, like kind of like TMUX style splits, has GPU acceleration. These are nice modern features. But yes, I love tinkering with terminal bling, I guess. Any other questions or comments? Grievances? Unrelated rants?
No, great job here. I'll hit stop unless other people have comments or stuff, and then we can go into the stuff we didn't want to get captured by the recording part of the discussion, which I don't have anything, but
I want to give you my thanks, of course, Jordan. That was a very practical point of view for something that, although a hobby, it's actually quite relevant for a lot of people.
Yeah, and if you think of any follow-up questions, feel free to pick me on Slack.